Hello everybody, welcome back to the shop and welcome to another episode of Old Engine Basics. And today we're going to be covering spark ignition. Now, spark ignition, any kind of spark ignition, would not be possible if it weren't for inductance, which is the generation of an electric current through a wire or through a coil as a magnet or a magnetic field passes through that coil. This is used in both low tension and high tension ignition systems, which I'll cover in a minute. This concept is still used by your 2017 Honda Civic or whatever. It still uses this same principle. Here is the most basic form of electric spark ignition. This is low tension ignition. And low tension ignition is used solely on igniter fired engines. And I'll show you what an igniter looks like in a minute. I don't have any here in the shop with me. But, well, basically on the inside of the engine there is just a set of points, and I'm sure most of you guys out there are familiar with what points are. Just a set of contacts that open and close. They make contact and they break contact. And those points are on the inside of the engine, on the inside of the cylinder in the combustion chamber. And the way it works, it's very simple. There's a power source. In this drawing, very simple, it's a battery. You could also use a Magneto. There's a coil and your igniter. When the igniter closes, it creates a full circuit. Current flows through the circuit, generates a magnetic field within that coil. When those points open, or when the igniter opens, that flow of current is broken, so that magnetic field is going to collapse. And as that magnetic field collapses, that magnetic field is actually moving through that coil. So the movement of that magnetic field induces a current in that coil. And that current, it's a very, let's see if I can remember this, very high voltage, but very low amount of current, very low amps, very high volts. And that's important because you need high voltage to jump a spark gap inside a engine, inside a cylinder. I'm getting a little off track here, but when the piston comes up on compression, you have high pressure inside the cylinder, and that means all the air molecules are tighter together, so it takes more voltage for a spark to jump through that compressed air inside the cylinder. So you could have a Magneto or any ignition system creating a spark on a spark plug in atmospheric conditions, but under compression in an engine that may not be the case, because you need a lot more voltage to jump the same gap, because there's more air in the way because of the compression again. So anyway, the reason I went off on that track is because you do need a higher voltage spark to actually jump that gap. So anyway, when the igniter opens, the magnetic field will collapse, induce a current through this coil. It'll go through the wire, and of course all this happens so quickly that the points, or excuse me, the igniter is just ever so slightly open. It's not fully open yet, so that current will jump the gap. It'll jump across the gap of the igniter points, and that'll cause a spark sufficient to ignite the fuel-air mixture inside the cylinder. These are clearly very simple ignition systems, but the downside is that the points, firstly, it's a mechanical thing and that can wear out, and also the contacts themselves can wear out and burn, and they need refreshing occasionally. Now, high tension ignition is a little more complicated, but it uses the same principles. If you follow this circuit diagram here, we still have our low tension igniter circuit. There's a low tension coil, a switch, in this case it would be points, a power source, and of course that all goes to ground, makes a circuit. But wrapped around the coil, what in this case this is called the primary coil, there is a secondary coil. Now another thing about this whole inductance concept is that you can use this to step up or step down voltage depending on the number of turns in your primary coil and the number of turns in your secondary coil. That's also what's going on in the transformers that are on your power lines, your telephone lines or poles that deliver power to your house. The line voltage on a power line along the road, I don't know what voltage it is, but it's a lot higher than what you get into your house, and those transformers step down the voltage with this same concept. So you have your 12 volt or 6 volt in some cases power going through your primary coil, and when the points open, again that creates a collapsing magnetic field. The magnetic field that was present in this primary coil is now collapsing down because there's no current flow, and that collapsing field, as it passes through your secondary coil, induces a current in your secondary coil. And again, because of the difference in the number of turns between the two coils, the voltage in the secondary coil is much, much, much higher than your power source voltage, 12 volts let's say. So that power, or that current, excuse me, goes through your spark plug wire and jumps across the spark plug gap on your spark plug and then returns to ground. Now in these two drawings I have used a battery as the power source, but a battery is definitely not required for spark ignition, whether it's high tension or low tension ignition. With a magneto application, and most of our engines, most of our hit and miss engines have magnetos, the magneto provides that power. It converts motion, typically either a rotary motion or a impulse or a flick motion, into power, into electrical current. Now with that being said, our classroom session is done. Let's take a trip over to the Zagre Farm Museum and take a look at a couple of my engines that have examples of both of these types of ignition. Alright, here we are at the stationary engine building at the Zagre Farm Museum. I have my 4.5 horsepower United engine stored here. Now you'll have to bear with the somewhat dark lighting, but this should illustrate what an igniter fired engine looks like. As you see, here's the external trip for the igniter, and then here is the trip rod. The trip rod is attached onto the push rod, the exhaust valve push rod, and that's it. There's one wire, one hot wire, and then a ground wire just attached onto the frame ground, and that goes to the contacts inside. I'm not going to take this off to show you the contacts themselves because I would ruin that gasket. I don't feel like making another gasket, but I'm sure all of you have seen points before. They just open and close, make and break contact, and that's all that's going on inside when this closes and opens again. Now this particular igniter, you'll see that it has two sort of different movements. There's this little bit of movement. It'll move freely and then stop, and then this part, just the top part, will turn, but it is held back with this very heavy coil spring. What's happening here is that when the push rod comes forward, it'll push this latch, trip latch I guess you'd call it, push it, and everything will move just a little bit. That'll close the points, and then as the trip rod comes forward more, it'll turn this, and then that little adjustable wedge there will start to raise this whole push rod up. When it raises it up, it'll delatch the push rod or the trip rod from the trip here, and then it'll snap it open, and when it opens, that'll make a spark and make it fire. But the reason there's this extra springy thing here is so the push rod can continue to push this, and it's not just forcing the points together harder and harder and making it break something. Now, as far as high tension or spark plug ignition is concerned, there's generally, as far as I've seen, two sources of the spark for these small engines. One source is a battery and buzz coil, and I have it set up sort of roughly on my 3 horsepower Fairbanks Morse Model Z. It is not the correct setup. The Magneto mounts right here, and that is what would normally fire the engine, but the mag needs work, so I did a quick and dirty setup with a buzz coil. This is a Model T Ford buzz coil. Inside it there's a high and low tension coil, primary and secondary. You can actually see the primary coil ends right there. That's the bundle, those little wires there, that's the iron core, and of course that's wrapped with wire. That primary coil, by the way, makes an excellent low tension coil. Anyway, there's 3 leads on this box here. There's a ground, I believe the ground is the bottom. There's the high tension spark plug lead and a battery lead. The way this works, or at least on this setup here, ground is just ground, of course. I made a trip. This is just a piece of metal, and as this flyweight comes around, this flyweight is actually the advance and retard function for the original Magneto. But as this comes around, it touches this little wiper here, and it makes and breaks contact. So that makes and breaks battery 12 volt voltage to the coil, which will make the points vibrate and then stop them from vibrating when that weight passes by the wiper. And then when it does touch the wiper, it'll make the coil fire and send a spark to the spark plug. Now here's an example of a Magneto ignition. This is a Wyco EK mag on my Stover Model KA, and this is I think it's a Model R Magneto. But anyway, this is on a 3 horse Fairbanks Model Z. And they all work slightly differently, but the concept is roughly the same, where there's a magnet and of course a magnetic field that passes through a coil of some sort, and that induces a current in that coil, and then due to a primary and secondary coil being in the mag, it creates a high voltage spark. Actually, now that I'm talking, I'm somewhat wrong. This is a low tension coil, Magneto. See, this engine also has points right there. So what this really is just it's almost just a generator creating a constant 12 volts or so, and then when the points open and close, that will make a low tension spark. But anyway, this is a Wyco EK. This is a high tension spark plug Magneto, and it works that same way of using a moving magnetic field through a primary and secondary coil. Okay, so what we have here is the buzz coil, or a similar buzz coil to what was on my Fairbanks Morse Model Z engine, and I thought I would do a little demonstration in the shop here to show you how this thing works, and just kind of give you a better idea of what's going on. I wasn't able to do this at the farm because everything is pretty well packed and cluttered in there, and I didn't have much space to move around. But again, here's a look at the coil, at the buzz coil, and one of the covers is off. It was missing when I bought this one. You can kind of see what's going on inside here. These are the secondary coils. As you can see, there's two of them, and then right through them in the middle is the primary coil, and again you can see the primary right there. That's the iron core of the primary. These are the points, and then hiding in here underneath this tar or pitch or whatever it is the condenser. And the condenser is needed, this is the extent of my knowledge, but it has something to do with balancing the voltage or something on either side of these points, so the points don't wear out like they would in a low tension ignition application. So with a condenser, you can make these points last a lot longer because it won't spark across the points when they make and break contact to the primary coil. So the buzz coil is also a little bit unique. It's a little bit different than the quick and dirty diagram that I drew for you, because what this will also do, it'll oscillate itself. It'll make a continuous spark. In something like an old car with a points ignition system, the points are opened once by the cam in the distributor, and that makes a spark. But in this case, when the primary coil is energized with a battery, of course that creates a magnetic field like we discussed, and that pulls these little points away. And then when it pulls, I don't know if you can see that move, but it pulls the points away, and when it does that, it breaks the primary circuit. So the magnetic field collapses and it makes a spark. But once the field collapses, there's no more magnetism, so these little spring-loaded points flip back up in their original position, and they make contact again, and it makes a magnetic field again, which pulls the points away again, which breaks the field, which makes a spark, and it goes over and over and over. So that's something a little bit unique and different about these buzz coils, and the reason they're called buzz coils is because they buzz. So I'll set it up for you. As you can see, this is the spark plug lead. This is not a Ford coil. I don't know what this is, but it already has a nice spark plug high tension terminal mounted on it, which is convenient. Now I have just an old regular spark plug and wire from off of my John Deere dozer. This is ground, so I just have a piece of wire in here to connect everything to. And then this is the positive. There you go. That's sparking. And you can see it's too fast to see, but that's wobbling back and forth. And of course there are some small sparks coming off of that. I don't know, this very well could have a bad or not so great condenser, or maybe that's the correct amount of sparks to have anyway. I'm not too familiar with the care and operation of these coils. So I think that's about it. Hope this clears up some of your questions, and if not, make sure to leave a comment down there and ask away, fire away, leave a comment, let me know what you think. And if you enjoyed this, if you enjoy my other videos, make sure to hit the subscribe button, of course, hit the like button. And I'll see you again next time. Like I said, it's getting colder outside and I'm in the shop more, so I'm making more videos for your enjoyment. Thanks for watching, everybody. Stay tuned for more.